For this problem, we're asked to look at this chain. There's an axial force of 600 pounds acting on the end. The force is applied to a cable. The cable is attached to a pin, which is in turn attached to the chain. The diameter of the pin is 0.25 inches. What we want to do is find out the average shear stress of that pin due to that 600-pound load. Our process here is to first look at an appropriate FBD. What I'm going to do is look at a free body diagram of the cable. And as the cable then connects to that pin. So here is the pin. We have 600-pound force. We have a shear force on this side. This is a case for double shear, double-sided shear. So when I sum forces on this, and I'm going to call this X and Y, when I sum forces on Y, I get 2V minus 600 is equal to 0 for equilibrium. So the shear force on each side of that pin is 300 pounds. But that shear force acts over an area, which is given by pi r squared. So tau, the shear stress on the average, is given by V divided by A. So that's 300 pounds divided by the cross-sectional area of that pin, which is pi d over 2 squared like this, where the diameter of the pin we know is given to be 0.25 inches. And that's it. The key thing here is drawing the free body diagram. We can classify something as single-sided, double-sided, but it really all comes down to that FBD. We see that since there is a support on both sides, there are two shear forces that are resisting that 600-pound load. Hence, it's a double-sided shear. What that means is that each side only carries 300 pounds, and that's the shear force we use in order to calculate our shear stress.